Hello friends, in today's session we are going to see more functions in package java.lang. Okay, so now we will start with the methods defined by long. Okay, static integer bit count long number returns the number of set bits in number. Byte value returns the value of invoking object as a byte. Integer compared to long L compares the numerical value of the invoking object with that of L. Return 0 of if both values are identical. Returns a negative value if the invoking object has a lower value. Returns a positive value if the invoking object has a greater value. Static long decodes string throws numbers format exception. Returns a long object that contains the value specified by the string in str. Okay, so now double value returns the value of the invoking object as a double. Boolean equals object long object returns true if the invoking long object is equivalent to long object, otherwise it returns false. Float value returns the value of the invoking object as a float. Static long get long string property name returns the value associated with the environmental property specified by the property name. A null is written on failure. Okay, so get long will give you uh, whatever property you are specifying in the bracket, its long representation will be written. Okay, and if it is written, if it is fail, it will give you null. Then static long get long returns the value associated with the environmental property specified by property name. The value default is written on failure. Okay, in this case null is written on failure because no any value is specified over here, and in this case default value is specified. If null is there, it will return the default value. Static long get long string property name long get default returns the value associated with the environmental property specified by property name. The value of default is written on failure. Integer hash code returns the hash code for the invoking objects. Static long highest one bit long number determines the position of the highest order set bit in number. It returns a value in which only this bit is set. If no bit is set to 1, then 0 is returned. Then integer int value returns the value of the invoking object as an int. Long value returns the value of the invoking object as a long. Static long get long string property name. I think these functions are double. Okay. Static long parse long string str throws number format exception returns a long equivalent of the number contained in the string specified by str in radix 10. Static long parse long string str integer radix throws number format exception returns a long equivalent of the number contained in the string specified by the str and the specified radix. Okay. Static long reverse long number reverses the order of the bits in number and returns the result. Then static long reverse bytes long number reverses the order of the bytes in num and returns the result. Static long rotate left long number integer n returns the result of the rotating number left in position. Static long rotate right long number integer n returns the result of the rotating number right and positions. Okay. Then static integer sinum long num returns -1 if number is negative, 0 if it is 0, and 1 if it is positive. Short value returns the value of the invoking object as a short. Static string to binary string long number returns a string that contains the binary equivalent of the number. Static string to hex string returns a string that contains the hexadecimal equivalent of the number. Then static string to octal string long number returns a string that contains the octal equivalent of the number. String to string returns the string that contains the decimal equivalent of the invoking object. Static string to string long number returns a string that contains the decimal equivalent of the number. Here nothing is specified in brackets, so it will give you decimal equivalent of the object, and here you are specifying the long number, so it will give you the decimal equivalent of these numbers. Static string to string long number integer radix returns a string that contains the decimal equivalent of the number using the specified radix. Static long value of long number returns a long object containing the value passed in number. Static long value of string throws number format exception returns the long object that contains the value specified by the string in str. Then static long value of string integer radix throws number format exception returns a long object that contains the value specified by the string in str using the specified radix. Now, converting numbers to and from string. One of the most common programming chores is converting the string representation of number into its internal binary format. Okay. Fortunately, Java provides easy way so that you don't have to worry about it. The byte short, int, and long classes provide the parse byte, parse short, parse int, and parse long methods respectively. Okay, so conversion of string representation of that particular byte or short or integer or long is very much easier. This method return byte short int long equivalent of the numeric string in which they are called. Similar methods also exist for float and double classes. The following program demonstrates the parse int method. It sums the list of integers entered by the user. It reads the integers using readline and uses parse int to convert the strings into integer equivalent. Okay, so parse demo is there. First of all, for using buffer reader, input is taken from user. It will be stored as a string str. Okay, enter number 0 to quit. So whatever string will be stored, it will be from user input and it will be stored into string. And I is equal to integer dot parseInt string. So I is now integer value and str is string. So its string is converted to integer and stored into I. And if this string cannot be converted to integer, if it is contain any alphabetical character, so it will give you number format exception. Then I is initialized with 0 again. Sum is equal to sum plus I. So every number that is user is entering, that will be added up and output is printed. Current sum is sum. Okay. So whatever is written inside the do while loop, whenever user is entering any value, it will be stored in string first, then it will be converted to integer, then it will be added to sum, then it will be printed current sum. Again, if user is entering non-zero value, then it will be again taking input, again it will be converted to integer, again it will be added to sum, and again it will be displayed with the final current value. Okay. Now, to convert a whole number into decimal string, use the versions of two strings defined by byte short int or long classes. The integer and long classes also provide the methods to binary string, to hex string, and to octal string, which convert a value into binary, decimal, octal respectively. The following program demonstrates binary, hexadecimal, and octal conversion. Only two string is not available, two binary string is available, two hex string is available, two octal string is also available, and these methods are also available, so you just have to call them. And how to call them we will see now. String convergence, number 19648, any random number is taken over here. Number in binary is presented, integer 2 binary string number, integer 2 octal string number, integer 2 hex string is displayed over here. Okay, so 19648 in binary conversion is this, in octal it is this, and in hexadecimal it is this. Okay, so these three functions you can take advantage of this. If you don't know the binary equivalent of this number, then binary string equivalent is not known, octal string is not known, or hexadecimal string is not known, you can directly call this. Okay, then character is a simple wrapped around character. A constructor for character is char. Here CA specifies the character that will be wrapped by character object being created. Okay. Okay. To obtain the character value contained in character object, call character value. Okay. Max radix, largest radix, minimum radix, the smallest radix, max value, the largest character value, minimum value, the smallest character value, and type is the class object for character. Character includes several static methods that categorize characters and alter their case. Now we will see those tables. Static boolean is defined, character ch returns true if ch is defined by Unicode, otherwise it will return false. Then static boolean is digit returns true if ch is digit, otherwise it will return false. Static boolean is identifier ignorable, returns true if ch should be ignored as an identifier, otherwise it will return false. Static boolean is ISO control character ch returns true if ch is an ISO and control ISO control character, it will return false otherwise. Then static boolean is Java identifier part character ch returns true if ch is allowed as a part of Java identifier other than first character, otherwise it will return false. Static boolean is Java identifier start character ch returns true if the ch is allowed as the first character of the Java identifier, otherwise it will return false. Static boolean is later character ch returns true if ch is a later, otherwise it will return false. So whenever you are declaring any Java identifier, you can check if if it is valid identifier or not using these two methods, Java identifier part. So if you are entering any number, any special character, so you can check if it is allowed to have such an identifier in Java. Here, if any identifier in Java as a start character, if it is allowed, it will give you true. You can check it out. Okay. Static boolean is later character ch returns true if ch is a letter, otherwise it will return false. Static boolean is letter or digit character ch returns true if ch is a letter or digit, otherwise it will return false. Static boolean is lowercase character ch returns true if ch is a lowercase letter, otherwise it will return false. Static boolean is mirrored character ch returns true if ch is mirrored Unicode character. A mirrored character is one that reverses for text that is displayed for right to left. Okay, means mirroring is performed over here. Reverse for text that is displayed right to left. For example, if your input string is ABC, your reverse string will be CBA. Okay, that is called as mirror character. Returns true if the CH is mirror Unicode character. Space character returns true if Unicode space character. CH is space, otherwise it will return false. Title case, CH is Unicode title case character, otherwise it will return false. Static boolean is Unicode identifier. Returns true if ch is allowed as a part of Unicode identifier other than the first character, otherwise it returns false. Static boolean is Unicode identifier starts character ch. Returns true if ch is allowed as the first character of the Unicode identifier, otherwise it will return false. Static boolean is uppercase character ch. Returns true if ch is an uppercase letter, otherwise it will return false. Static boolean is white space character ch returns true if ch is a white space, otherwise it will return false. Static character 2 lowercase character ch returns lowercase equivalent of ch. Static character 2 title case character ch returns title case equivalent of the ch, that is capital case. Title case. And static character 2 uppercase returns uppercase equivalent of the ch. Now, several of these methods we will explain here. A, B, 5, question mark, A and space. Okay. For integer I is equal to 0, I less than a dot length I plus plus. So this is the array. I will iterate here, and every function is tested over here. If character is digit, a of I is a digit. Else if character is letter, it will print ai is letter. If it is white space, it will display ai is white space. Is uppercase, it will display a of I is uppercase. Otherwise, it will lowercase. Okay. A is a letter, A is a lowercase, B is a letter, B is a lowercase, 5 is a digit, 5 A is a letter, A uppercase, space is a white space. Okay. So now, what we have done in this program, only array is taken, and for each particular value, we will check if it is digit or if it is uppercase, lowercase character, and so on. Character defines two methods for digit and digit that enable you to convert between integer values and the digits they represent. Okay. Static character for digit, integer number, integer radix. Static in digit, character digit, integer radix. For digit returns the digit character associated with the value of the number. Okay. So whatever number you are specifying, its digit character will be written by using this for digit method. Okay, and the radix of the conversion is given by the radix. So for example, if you are character for digit, if you are specifying here number 9, what is the specified character for that particular digit 9? It will be written. And integer digit for particular character. So if you are specifying here A, it will return the 65. Capital A, it will give you 65. Digit space returns the integer value associated with the specified character, which is presumably a digit according to the specified reading. Another method defined by character is compare to, which has the following form: integer compared to character C. It returns 0 if the invoking object and C have the same value. It returns a negative value if the invoking object has a lower value. Otherwise, it will return a positive value. Character include a method called get directionality, which can be used to determine direction of the character. Okay, so you have to remember this. You can write this down. The method name get directionality. Several constants are defined that describe the directionality of the character. Okay, most programs will not need to use character directionality, so it is not famous for that purpose. But in case you require to find out the direction of character, you can find it out using get directionality. Character also overrides equals and hash code methods. Two other character related classes are character subsets, used to describe the subset of Unicode, and character dot subset, and character dot Unicode block. Okay, first class is character dot subset, which is used to describe subset of Unicode, uh, Unicode subset, and character dot Unicode block, which contains Unicode character blocks. Okay. Recent additions to character for Unicode code point support. Recently, major additions have been made to character. Beginning with Java 5, the character class has included support for 32-bit Unicode characters. In the past, all Unicode characters could be held by 16 bits, which is a size of character and the size of value encapsulated within a character, because those values range from 0 to FFFF. Okay. Unicode characters could be held previously by 16-bit, which is the size of char, because those values range from 0 to 4 times f. The Unicode character set has been expanded and more than 16 bits are required. Characters can now range from 0 to 104 times f. Here are two important terms: code point and supplemental character. The code point is a character in the range 13000 to 1024 times f. Characters that have values greater than 4 times f are called supplemental characters. Expansion of Unicode character set caused a fundamental problem for Java. Okay, because the supplemental character has a unique value greater than the character can hold, some means of handling the supplemental characters was needed. Java addressed this problem two ways. First, Java uses two characters to represent supplemental character. The first character is called the high surrogate. Okay, so what we are seeing over here, expansion of the Unicode character caused us some problems. Because the supplemental character has value greater than the character can hold, some means of handling supplemental characters was needed. And two ways to handle them are: first is two characters to represent supplemental characters. So what is a supplemental character? We will see. The first character is called the high surrogate and the second is called the low surrogate. New methods such as code point at were provided to translate between code points and the supplemental characters. Okay, the expansion of the Unicode character set caused a fundamental problem for Java. Because the supplemental character has a value greater than the character can hold, some means of handling the supplemental character needed. Okay. New methods such as code point at was provided to translate between code point and supplemental characters. Java overloaded several pre-existing methods in the character class. So first method is uh, first character high surrogate, second character low surrogate, such as code point at were provided to translate between code points and supplemental characters. Secondly, Java overloaded several pre-existing methods in character class. In addition to the methods overloaded to accept code points, character adds methods that provide additional support for code points. The sampling is shown in table. Now, static integer character counts integer CP. Returns 1 if CP can be represented by a single character. It returns 2 if two characters are needed. Static integer code point at character sequence characters integer location. Local returns the code point at the location specified by the location. Code point at location, sorry. Integer code point at character array integer location returns the code point at the location specified by the location. Static int code point before character sequence characters integer local returns the location returns the code point at the location that precedes the that specified by the location. Static integer code point before characters integer location returns the code point at the location that precedes that specified by the location. Static boolean is high surrogate character ch returns true if ch contains a valid high surrogate character. Then static boolean is low surrogate character ch returns true if the ch contains valid low surrogate character. Static boolean is supplementary code point integer cp returns true if cp contains a supplemental character. Static boolean is surrogate pair characters high ch character low ch if the high ch and low ch form valid a surrogate pair. Okay. So everything can be found out using these methods. Okay. This is for high surrogate. This is for is low surrogate. This is for a supplementary code point. So everything is given. Okay, in bits. So you just have to do what? You have to remember the syntaxes and what is it returning. Okay, so you can easily find it out. Then static boolean is valid code point. Integer CP returns to if CP contains a valid code point. A static character 2 characters integer CP converts the code point in CP into its character equivalent which might require 2 characters. An array holding the result is returned. Static integer 2 characters integer CP character target integer location. Converts the code point in CP into its character equivalent storing result in target beginning at location. Returns 1 if CP can be represented by a single character, otherwise 2 characters are needed. Okay. Static integer 2 code point character is high ch character low ch converts high ch and low ch into their equivalent code point. Okay. Now we will see for boolean. Boolean is very thin wrapper around boolean values which is useful mostly when you want to pass a boolean variable by reference. Okay. Whenever you want a boolean variable passed by reference, then boolean is a very thin wrapper class. It contains the constants true and false which define true and false boolean objects. Boolean also defines type field which is the class object for boolean. Boolean defines three constructors. First is boolean value. Second is boolean string. The first version boolean value must be either true or false. Second version boolean string contains the string true and in upper or lower case, then the new boolean object will be true. Otherwise, it will be written false. Boolean defines the method shown now. Boolean value returns the boolean equivalent. Integer compared to boolean b returns 0 if the invoking object and b contain the same value. Returns a positive value if the invoking object is true and b is false. Otherwise, it returns a negative value. Boolean equals boolean object returns true if the invoking object is equivalent to boolean object. Otherwise, it will return false. Static boolean get boolean string property name returns true if the system property specified by property name is true. Otherwise, it returns false. Integer hash code returns a hash code for the invoking object. Static boolean parse boolean string str returns true if string contains the string true. Case is not significant, otherwise it will return false. So true can be written T capital, RU in small, whole thing is strong, whole thing is in capital, whole thing is small. String to string returns the string equivalent of the invoking object. Static string to string. Boolean value returns the string equivalent of the boolean. Static boolean value of boolean bool value returns the boolean equivalent of the boolean value. Static boolean value of string boolean string returns true if the boolean string contains the string true in upper or lower case, otherwise it will return false. Now void. The void class has one field type which holds the reference to the class object for the void. You do not create instances of this class. Okay, so void is returning nothing. We have already seen void. Then we have seen method return type as void. Void means what? Void is returning nothing. Has one field type which holds the reference to class object for type void, and you cannot instantiate. Process. An abstract process class encapsulates a process that is executing program. It is used primarily as a superclass for the type object created by exec in the runtime or by start in the process builder class. Okay. The abstract process class encapsulates a process. Process is program, and program in execution. It's called as process. Okay, we can call it as executing program. It is used temporarily as superclass for the type of object created by exec in the runtime class, or will execute the process and start in the process builder class. Okay, so now process contains the abstract methods. Void destroy terminates the process. Exit value returns an exit code obtained from a super process. Input stream get error stream returns an input stream that reads input from the process error output stream. Input stream get input stream returns an input stream that reads input from the process output stream. Output stream get output stream returns an output stream that writes output to the process input stream. Then integer wait for throws interrupted exception returns an exit code written by the process. This method does not return until the process on which it is called terminates. Okay, runtime. The runtime class encapsulates the runtime environment. You cannot instantiate this object. However, you can get a reference to the current runtime object by calling the static method runtime.getRuntime. Okay. Once you obtain the reference of the current runtime object, you can call several methods that control state and behavior of the Java virtual machine. You cannot instantiate first of all, but you can get a reference using runtime.getRuntime, and after you get the current state, you can if after you get the reference, you can call the several methods that control the state and behavior of the Java virtual machine, that is JVM. Okay, so these are the methods by runtime. Okay, after calling this runtime, you can use these methods. Add shutdown hook thread thrd registers thrd as a thread to be run when the Java virtual machine terminates. Process exec string program name throws IO exception. Executes the program specified by the program name as a separate process. An object of type process is returned that describes the new process. Then process exec string program name string environment throws IO exception. Executes the program specified by program name as a separate process with the environment specified by environment. An object of type process is returned that describes the new process. Process exec string command line array throws IO exception. This is the array. Executes the command line specified by the strings in command line array as a separate process. An object of type process is returned that describes the new process. Okay, so process will be returned in this case, and IO exception is thrown. Then process execute string command line array string environment throws IO exception here also. Executes the command line specified by the strings in command line array as a separate process with the environment specified by environment. An object of type process is returned that describes the new process. Void exit integer exit code halts the execution and returns the value of exit code to the parent process. By convention, 0 indicates the normal termination, all other values indicate some form of error. Okay, if you want the normal termination, it will be 0. Okay, exit code is 0, otherwise it is error code. Long free memory returns the approximate number of bytes of free memory available to the Java runtime system. Okay, approximate memory is very much large, and so it is written in the form of long. It cannot be written in the form of int. Although it is an integer number, but a small integer, it's only a 32-bit. It cannot hold a very long number, and our computer or our PC or our laptop has very large memory, so that number should be hold in a very large format of primitive type, and that is primitive type is long. Okay, so it will be written in a long format. Void garbage collection initiates the garbage collection. Static runtime get runtime returns the current runtime object. Void halt integer code immediately terminates the Java virtual machine. No termination threads or finalizers are run. The value of code is returned to the invoking process. void void loads string library file name, loads the dynamic library whose file is specified by library file name, which must specify its complete path. Then void load library string library name loads the dynamic library whose name is associated with the library name. Boolean remove shutdown hook thread removes the thread from the list of threads to run when the Java virtual machine terminates. Okay, then whatever thread you are specifying, that will be removed from the list of threads. Okay, when the Java virtual machine terminates, it returns true is successful. If otherwise, it will return false if the thread is removed successfully. Okay, when the Java virtual machine shutdowns, whatever thread name you are giving, that will be removed from the thread list, and if it is removed successfully, it will give you true, that is successfully removed. Run finalization initiates call to finalize methods of unused but not yet recycled objects. Long total memory returns the total number of bytes of memory available to the program. Void trace instructions boolean trace on turns on or off instruction tracing depending on the value of trace on. If trace on is true, the trace is displayed. If it is false, tracing is turned off. Void trace method calls boolean trace on, turns on or off method called tracing depending upon the value of trace on. If trace on is true, the trace is displayed. If it is false, tracing is turned off. Okay, let's look at two of the most common uses of runtime: memory management and executing additional processes. Memory management is the first use. Although Java provides automatic garbage collection, sometimes we will want to know how large the object heap is, how much it is left. Okay, so how memory is managed, you want to know. So at some time, you can use this information, for example, to check your code for efficiency or to approximate how many more objects of a certain type can be instantiated. Okay, if you know exactly how much memory is left, then you can decide if I can instantiate or I can create the object of some classes or some type of primitive types or not. Okay, so for that purpose, you may want to know how much memory is exactly left. Run finalization initiates call to the finalize methods of unused but not yet recycled objects. Long total memory returns the total number of bytes of memory available to the program. Void trace instruction boolean trace on turns on or off instruction tracing depending upon the value of trace on. If trace on is true, the trace is displayed above. If it is false, tracing is turned off. Void trace method calls boolean trace on turns on or off method called tracing depending upon the value of trace on. If trace on is true, trace is displayed, otherwise tracing turned off. Okay, this way we have seen many more topics related to java.lang package. We explored today Java long class, that is long long primitive type wrapper class. Okay, in the next session, we will see some more remaining topics, more interesting topics in Java lang package, and then we will start with the practical part. So meet you in the next session. Thank you so much.